Let's move on to the next presentation, which will be given by Isabella Procopio, I think. This is INCEFA PLUS, which is, I guess, an acronym of a sophisticated long title. We will hear it immediately. Please, floor is yours.
So I'm Isabella, as the chairman said. I work for the University of Cantabria in Spain, and I'm going to introduce the INCEFA PLUS, which is an European project. INCEFA stands for Increasing Safety in Nuclear Power Plants by Covering Gaps in Environmental Fatigue Assessment. So the contents of this presentation: first I will introduce the project, then I'll talk about the project background, its organization, the tests that has been performed and are being performed, and the dissemination. So first, the introduction. So this is a 5-year project. It started in 2015. The total value of the project is 7.5 million euros, which 2.5 million is supported by a European Commission Horizon 2020 program. So these are the 16 organizations that are members of the project. They all have the same goal to deliver new experimental data in order to develop improved guidelines. So we already have some guidelines for the assessment of environmental fatigue. But in this case of this project, we want to develop improved ones. All of this with the goal of ensure safety in nuclear power plants. So as you can see, there are organizations from all over Europe. Now the project background, why the project started. So in 2007, the NUREC CR 6909 guide has been published, and it was adopted worldwide in various forms. So what happened was that the labs worldwide increased their focus on trying to understand the real plant experience against what the guide said. So it has been noticed that the guide was over-conservative. So even though they have a lot of data for this guide, there were some gaps in this field of study. So these gaps were reviewed in 2011, and they were updated in 2013 with another European project called INCEFA. So the conclusion of this INCEFA project was that some common interest in further study in mean stress and mean strain, hold time and surface finish was desired. So that's why in 2015 INCEFA became INCEFA PLUS, and all of these variables needed to be studied in light water reactor environment. So the project organization. The project is divided into 4 work packages. The first one is the project management. The second one is the test program. The third one is fatigue assessment procedure development. And the fourth one is dissemination and training. This fourth one is what us as University of Cantabria are responsible for. So the work package 2, test program. The tests are expected to take 3 years. It started in December 2016. 12 members of the project will test in common material, which is a 304L stainless steel. And the specimens are supplied and manufactured by the same member of the project, which is EDF. So this guarantee that improved quantification of variability between partners. So if we are performing tests in the same material and the specimens are made in the same place, there are less variability. Another important thing here to say is that all of them are performing in the same agreed test protocol, and they all supply data in the same agreed format. So we test both in hollow and full specimen. In the hollow specimen, there is a hole in the specimen, and the light water environment is here inside the specimen. And the full specimen, the light water reactor environment, is outside the specimen. So another important thing in the work package 2 is the material characterization program. So basically, if we have an outlier, we can see if there is something about the microstructure that generates this outlier or not. The surface finish of the specimens, they are all manufactured in the same facility, so this generates consistency between the surface finishes. And the test matrices of the project has been developed using the design of experimental methodology. So this design of experiment methodology, it guarantees interdependency between sensitivities. So in the case that one sensitivity can be affected by the variation of another, this will be taken into account. So the work package 3, fatigue assessment procedure, it has basically two parts. The first one is already completed, which was the fatigue standard data format, which has been developed in a fatigue assessment workshop. And the second one is the procedure itself. So here basically there are going to be some statistical analysis. It is not completed yet because the tests are not finished and some of them still need to be validated, but some statistical analysis will be performed. And last but not least, the work package 4, which is dissemination and training. As I said, we as University of Cantabria are responsible for. So we have a website, we have organized a seminar, another one is taking place in 2020. We have to deliver a reference book, and we organize sessions in international conferences. So the key deliverables to this project include a protocol for environmental assisted fatigue testing, which might become an ISO standard. New fatigue curves and probably modified analysis procedure leading to the reference book, which I mentioned before. This is suitable for possible conversions to assessment standards. And publicly citable quality data points from tests on fully characterized test materials. So now, before I talk about the tests themselves, I have to say that data scatter is a key issue affecting conservatives. So as I said, the 6909 is over-conservative, so here we need to address the data scatter. Some data scatter is inevitable due to material variability. In this case of this project, some remaining data scatter is present due to variations in material conditions, specimen design, rig alignment variability, etc. But we are trying to reduce this data scatter as much as possible by everybody working in the same agri-test protocol, as I said before. So the specimen machining and geometry requirements all the same for all partners, the rig requirements, the standard test conditions, everything standardized for all partners, all members of the project. Data recording, so when they record the data and when they deliver the data, it has to be all standardized. And the way the tests start and the way they conclude has to be the same for all partners. What else are we doing to reduce the data scatter? All results being graded for quality, so the data has to be complete and it has to be high quality. So since the quality is something that is not tangible, it is judgmental, so the consortium appointed five expert people in the group, which they call the expert panel. So they are empowered to score all data and to challenge the originators of the data to do what is necessary to improve the data quality. And another very important thing is the acceptance. So the acceptance that data failing quality or completeness criteria could be disallowed for consideration. That means if the data is not complete or if it's not high quality, it will not be accepted. So the tests are divided into 3 phases. The first one is already completed. 74 tests has been performed. 65 of them using the common material that I mentioned before. They are performing according to a test protocol. Initial review of raw results has already been done to help specify the phase 2 testing. Expert panel, which are the 5 people that I've just mentioned. The review of the phase 1 is completed already. And the data refinement is underway following the expert panel review. The phase 2 is where we are right now, so the testing are underway. The test matrix is very similar to the phase 1 test matrix, except that no further strain control test will be done since we already have enough data for this condition. And in the phase 1, we haven't noticed any effects, which is consistent with what we expected and with literature. So in phase 2, no further strain control test will be performed. And the test in air will be at increased strain rate. So this will allow us to do the test in less time. So this will improve test efficiency. And the last difference between the test 1 and the test 2 test matrix is the exploration of effects of surface finish in more detail in rougher surface. So the surface finish that we test in the phase 1 is with RT between 20 to 35. So now we will test RT higher than 40, and this way we can explore this condition in more detail. And the phase 3 is likely to commence by the end of this year or at the beginning of next year. So here, just to have an idea about the whole time. So in air, for example, with a strain amplitude of 0.3%, every 6,000 cycles we'll do a hold. So in light water reactor environment, with the same strain amplitude, every 1,200 cycles. And about the mean strain, so the strain amplitude, the same strain amplitude that you can see here, we will do the mean starts at 0, so it goes to minus 0.6 to 0.6, and the hold will be done at 0. So it's not
3 minutes.
Okay. So currently it's not possible to show results plotted, but we do have some trends. For example, we have noticed an effect of the light water reactor environment on low cycle fatigue. We have noticed that for a roughness surface, there is less effect in light water reactor environment than there is in air. About the whole time, the only effect has been apparent at the low strain amplitude in pressurized water reactor environment. About mean strain, no effect of mean strain has been seen, and also no significant variability between laboratories. So here's the CR6909 curve for pressurized water reactor, and this is for air. And these are some tests that we have performed. So we see that it's close to the line. And also here you can obviously see the effect of pressurized water reactor environment. And the last part of my presentation is the dissemination, which I will repeat us as University of Cantabria are responsible for. So we design a website telling what the project is, what we're doing, the news. We have a Twitter account, so we follow people in the same field of study, and they follow us, they know what we're doing, we know what they're doing. We have a ResearchGate profile. So here you can see a snapshot of the web page. I will leave you the link at the end of the presentation. We also organize special sessions in conferences such as ICMFM 2016 in Spain, another one this year in PVP in Prague. We have published many scientific papers. We present in conferences such as this one. In June of this year, we organized a 1.5-day workshop with 65 attendants in Spain, and another one is expected to take place in June 2020. And by the end of the project, we need to deliver a reference book with the summary of all data generated in the project, the developed fatigue assessment procedure, which is the work package 3, all of the results of the project, and all the conclusions. So thank you very much for your attention.
Thank you very much.